Right, so to crank through this real quick, what we're asked to do is find theta, right? So whenever you want to find theta, and let me zoom in on this a little bit, I have to pick from SOHCAHTOA. So in other words, do I use sine? Do I use cosine? Do you use tangent? Well, it depends on what sides they give us. Here's theta here. What's this? This is the opposite. What's this? This is the adjacent. Right? Well, that's tangent, isn't it? So I would say to find theta, it is tan inverse or arctan of the opposite over the adjacent. Okay? Or arctangent of 14 over 7. Now that reduces down to 2, but you could actually just plug that in the calculator like that. So if I go and I say tan invert, or I'll say arctan, arctan 14 divided by 2, and I really wish that I had the emulator set up, but yes.
It's by 7. 14
oh, by 7. You're right. See what I did there? Thank you. By 7. Now, this is giving me the answer. Actually, you know what? Let's just use the Desmos one. I'm just going to use Desmos. Google has a pretty good calculator, but I think Desmos, at some point, they're going to be using that on the SAT. So I need arctan. So if I go to function, right, I'm going to say arctan, and I'm in degree mode. So that's kind of important. And then let's go back to the main, and it's 14 divided by 7, which is actually 2, right? 63, this is the answer right here, right? 63.43. And so guess what? 63.4, right? So this is approximately 63.43 ... See how that works? Any questions on that? Let's move on to example number 2. We're going to rapid fire these bad boys. Same thing here. This is theta. So then over here, this would be the opposite because it's across from theta. This touches theta, so this would be the adjacent. So theta is equal to arctan of the opposite over the adjacent. So I would say arctan of what's the opposite? 5 over the adjacent, which is 14. So I'm going to plug this in my handy dandy calculator, and I'm going to go again. Arctan, what was that? 5 over 14? Yeah. 19.65 roughly, right? See that? So yeah, 19.65. Okay. Now the real challenge were for like question number 3. So let's do question number 3. I'm recording a video of this, so if I go too fast, and I'm sharing these notes are already posted in Canvas. So, all right. Now for this one, we need to figure out sine of theta. So remember that sine of theta is equal to the opposite over the hypotenuse, right? So what did they give me? Well, this is the hypotenuse, right? And this is the adjacent, but I don't have the opposite. So the Pythagorean theorem, you guys are used to seeing a squared plus b squared equals c squared. But now that you're in trigonometry, we're going to refer to that as O squared plus A squared. Right? The opposite squared plus the adjacent squared is equal to the hypotenuse squared. So let's plug in what we know. The opposite squared plus the adjacent squared, which is 15, is equal to h squared. Oh, this is fun. 5 times the square root of 10 squared. What's 15 squared? Huh? 225? Now over here, I know that we're not the most comfortable with square roots and stuff, okay? So as a side note, I'm gonna draw this out to kind of help us feel more comfortable with it. So if I say 5 square root of 10 squared, that's like saying 5 root 10 times 5 root 10. So you can also think of this as 5 times 5 times the square root of 10 times the square root of 10. 5 times 5 is 25. The square root of 10 times the square root of 10 is really the square root of 10 times 10, which is 100. What is that? Well, the square root of 100 is 10. So this is like 25 times 10. Now, normally when Mr. Adams does this, this is what I'm thinking in my head, but I skip a step from time to time, and sometimes that's, you guys are like, how'd you get that? Well, this is how. So I'm going to slow down and show you each step I'm thinking in my head. Eventually, when you do a lot of these, you'll start to skip a step. Yes?
You squared the 225.
Oh, you're right. Good catch.
I just want to make sure.
No, this is not squared. Good catch. So anyways, all of this is actually just 250. Okay. So now to solve this, what I'm going to do is I'm going to say the opposite squared plus, oh wait, let's back up. Let's subtract the 225, yeah? So I'm going to subtract 225 from both sides. And I get the opposite squared is equal to 25, yeah? So then I'm going to take the square root of both sides, and I get the opposite is equal to 5. So we had to do all that work so that I could say sine of theta is equal to the opposite, which is 5, all over the hypotenuse, which is 5 root 10. Now what happens with the 5s, folks? Well, 5 divided by 5 is just 1, isn't it? 5 divided by 5 would just be 1, right? So I have 1 over the square root of 10. Can I leave it that way? No, we can't have a square root in the bottom of a fraction. So to get rid of the square root, let me write this out so you guys can see what I'm saying. This reduces down to this, okay? I can't leave it that way. So I need to multiply this by the square root of 10, and whatever I do on the bottom, I also have to do on the top. All right, well, the square root of 10 times 1 is just the square root of 10. The square root of 10 squared is just 10. That's our answer. Okay. All right, this next one's a little trickier. We're going to do problem number 4. I think I'm going to do one video for all of these just because I'm going to post one link for the video. It might be easier. You can fast forward through to the problems. Maybe I'll have those indexed. All right. Now, for cotangent, remember, and if you don't remember, cotangent of theta is the reciprocal of 1 over tangent of theta. What does that mean, Mr. Adams? Well, tangent of theta is equal to the opposite over the adjacent. So cotangent of theta is the adjacent over the opposite. Now, Mr. Adams can rattle this off the top of his head because I'm a math teacher, but you guys are learning this. You may not be familiar with this. So you can look this up, right? You can look it up in your notes when you're doing your homework, okay? And if you get a little cheat sheet too would be good to have these trigonometric ratios written down, right? The 6 basic ones, right? In a location that you can find, right? Put a star by it or whatever you got to do. So now I got to figure out what I have. I probably won't have something and have to solve for it. Maybe, maybe not. I don't know. Well, this is theta. Across from theta is the opposite. And the side that's touching theta is the adjacent. Holy moly, we don't have to do the Pythagorean thing, right? I just have to say 8 over 15. Easy peasy. Now, what was interesting to me on some of these, like on the previous example, I noticed on the previous example, kids just plugged in the numbers and didn't realize they had to solve for the hypotenuse. So sometimes you don't have to solve, sometimes you do. All right? You really got to think about that. Okay? Let's move on to problem number 5, shall we? And it's okay. All right. Secant is the reciprocal of which one? Cosine, right? Yeah. So cosine, remember, cosine of theta is SOCA, right? So then secant would be the reciprocal of that, right? So that would be the hypotenuse over the adjacent. All right, what did they give us? Well, here's theta. This is the opposite. Uh-oh. This is across from the 90-degree angle. So that's the hypotenuse. Wah, wah. We don't know what the adjacent is, and we need it. Oh. Who writes this test? So I'm going to say the opposite squared plus the adjacent squared is equal to the hypotenuse squared. 7 squared plus a squared is equal to 225 squared. This is 49 plus a squared is equal to 625, yeah? Somebody double check that on their calculator.
Yeah.
Yeah? Okay, good. I wrote 45. Why did I write 45? It's 49. So I get a squared is equal to, holy moly, what is that? 625 minus 49, I don't know. Let me just double check. 625 minus 49 is equal to 576. Okay. I wonder if that's 24 squared. Maybe. I don't know. Let's see. Oh, I got to clear this out. Yeah. Sweet. I know what you're thinking. Mr. Adams, you're like a wizard. I may have done this once or twice. Or 3,000 times. So when I take the square root of both sides, I get a is equal to the square root of 576, which is 24. All right, cool. I got 24 over here. Also, I know what the answer is, silly gooses. So the hypotenuse is 25, and the adjacent is 24. All right. Now, if I were to get some, you could for this 576, you could have gotten the 24 by hand by breaking this down into the prime factorization, right? And then find out what the squares were, right? In other words, let's do that real quick. If I were to say 576, think of two numbers that go into 576. Well, if I say 2 times this stuff, what would that be? 288. All right, so then 2 times, let's do 2 again. That's what, 144, right? Is that right? Okay, so then if I do this again, I've got 2 times 2 times 12 times 12. So I've got 2 squared times 12 squared, right? If I take the square root of this and the square root of this, which is essentially what we're doing, we're going to have 2 times 12. Guess what that equals? 24. Okay? Now I'm showing you this because sometimes you're going to have like a square root. In other words, it may not work out so nice. You might have like 3 root 5 or something, and this is the process you would use to simplify. Anyways, let's move on to the next one. Problem number 6. We're almost done. Bless you. Okay, same thing here, just like the other problem. Secant is the reciprocal of what? Cosine, right? So remember, SOCA, right? So then that would mean that cosine of theta is equal to the adjacent over the hypotenuse. So secant, which is the reciprocal of that, would be equal to the hypotenuse over the adjacent. What did they give us? Well, here's theta. Across from theta is the opposite. Over here, across from the 90-degree angle is the hypotenuse. But this is a famous triple, right? Do you guys know what this triple is?
3, 4, 5.
It's 3, 4, 5. We could verify it though, right? So let's just verify it just in case. So it's O squared plus A squared equals H squared, right? All right, so what's the opposite? 3 squared plus A squared. Don't know what that is yet. 5 squared. 3 squared is 9 plus A squared is equal to 25. Subtract 9 from both sides. I get A squared is equal to 16. Take the square root of both sides. And I get A is equal to 4. So over here, A is equal to 4. And then it's just 5 over 4. Okay. Any questions on that one? All right, let's move on. We're almost done. How are you guys feeling? I'm going through kind of fast, but is it making more sense?